The unique blue color seen from a satellite view of Utah's main national park is fascinating. Upon closer inspection, nestled amongst the canyons, a remarkable sight of 23 ponds, colored in shades of blue, yellow, and green, enhances the beauty of this area. But what is the purpose of these beautiful blue ponds in this wilderness of brown mountains and rocks? Are they part of a NASA secret project, or perhaps swimming pools? The real purpose is far more fascinating. To understand these stunning blue ponds, we need to travel back 1,500 years, when humans first discovered a unique chemical element with the help of bonfires. Yes, the same bonfires we light in winters to keep warm. The process is simple. Just light a few logs on fire, not for warmth this time, but for the ash that remains. This ash is placed in a pot, and some water is added. The ash contains various chemical compounds, some of which dissolve in water and change its color. The water is then filtered and left to evaporate in the sun. The remaining crystals are a chemical element that humans have been using for centuries. Since it is made with a pot and ash, it was named potash. Initially, people used potash to make soap, dye clothes, and produce glass products. For instance, melting animal fat and adding potash on top creates a liquid soap. Similarly, adding potash in glass production lowers the melting point of glass, making it easier to shape. With the growing human population, the demand for potash surged, leading to the establishment of thousands of factories by 1788, solely to burn wood and collect ash. In 1790, inventor Samuel Hopkins developed a new method for potash production, baking the liquid in ovens instead of in the sun. This method was quicker and became the first patent in American history, signed by George Washington. The patent brought significant attention to potash, leading scientists to experiment with it. Among these experiments, one conducted by Humphrey Davy in 1807 was transformative. He put potash in a pot and applied an electric current from a battery. He noticed the formation of tiny metal balls in the potash, which suddenly exploded. Davy had discovered a new element. Since it was derived from potash, he named it potassium. Potassium is commonly associated with apricots, raisins, or bananas, as they are good sources for humans, but they do not contain pure potassium, which is highly reactive. For instance, in Davy's experiment, potassium reacted with water vapor in the air and exploded. Therefore, pure potassium is usually stored in oil to prevent reaction with water vapor. Potassium's byproducts are used in numerous products today, from batteries to fertilizers, and from glass to gunpowder. Adding animal waste to potash produces potassium nitrate, a key ingredient in gunpowder and fireworks. After Davy's discovery, the main challenge was potash manufacturing, as it was still primarily produced by burning wood. The increasing demand led to deforestation in Europe and the US, posing an environmental threat. In 1861, Germany discovered a new source of potash in a specific type of rock, abundant in the country. This discovery was cost-effective and environmentally friendly, saving trees. They found that spreading potash on the ground accelerated crop growth with less water, a boon for farmers. By 1910, just before World War I, when the world was heavily dependent on German potash, Germany ceased its export, significantly impacting the US. This led the US Congress to allocate funds to find domestic sources of potash, including a location near Moab City in Utah. However, the potash deposits were 3,500 feet underground. Initially, the US dug mines to extract potash from these depths. Everything was going well until a tragic accident in 1963, when a methane gas leak in a potash mine ignited, resulting in a massive explosion that killed 18 miners. The following year, a Canadian mining company discovered a new method of extracting potash in Utah. They dug a shaft 3,500 feet deep, injected pressurized water, and mixed the potash deposits with the water. The water was then pumped to the surface into ponds. These are the same ponds we see today in various colors. The blue color of the water is not due to the pot content, but because copper sulfate is added to prevent bacterial growth and to attract more sunlight for faster evaporation. The sun's heat evaporates the water in these ponds, leaving behind pure potash. There are 23 such ponds spread over a 400-acre area in Utah. Each pond takes about 8 months to evaporate. As the water level decreases, the ponds change color from blue to green and then to yellow. Finally, white crystal potash remains, which is loaded onto trucks for transport. Potash has been a practical tool and a major source of income for humans for centuries. It's estimated that America can earn $660 billion from this location alone, as it contains 2 billion ton potash.